Welcome to our channel Sankalp Study Success. Today in this video we are going to learn about Poisson distribution. Till now we have seen what is binomial distribution. Now we will see what is Poisson distribution here, and we will also solve some of the problems related to Poisson distribution. So see, what is Poisson distribution? A discrete random variable x follows Poisson distribution, so it assumes only non-negative values of x, that is only positive values. See here, the formula of Poisson distribution is p of x is equals to e power minus lambda power x by x factorial, where x is equals to 0, 1, 2, 3 and so on. So all the values are just non-negative integers, that is only positive values. So e power minus lambda into lambda power x by x factorial is the formula to find out Poisson distribution. So here, if lambda is greater than 0 and it is called parameter of Poisson distribution, this lambda is the parameter of Poisson distribution. It is the parameter. Here, now we are going to see what is probability mass function of Poisson distribution. We have seen probability distribution of binomial distribution, probability mass function of binomial distribution, and in this video we are going to learn probability mass function of Poisson distribution. So, in order to find probability mass function, it should follow two conditions. Those are f of x must lie between 0 and 1, and also summation of x equal to 0 to infinity f of x, this value should be equals to 1. Then we can say that it is a probability mass function. Now coming to cumulative distribution function of Poisson distribution. Here cumulative distribution function of Poisson distribution is given as e power minus lambda into lambda power x by x factorial, where x is equals to 0, 1, 2 and so on. So all are the non-negative values, that means all are the positive integers. This is cumulative distribution function. So now let us see what is mean of Poisson distribution and what is variance of Poisson distribution. Let us prove this. Let us derive it. E of x is equals to summation of x equals to 0 to infinity xi into pi. This is nothing but generally it is mean, right? We already know this equation. We know that E of x is equals to summation of x equals to 0 to infinity xi pi. This is nothing but mean. So we can write it as summation of x equals to 0 to infinity x into p of x, right? Now, which is equals to summation of x equals to 0 to infinity x into what is p of x? It is nothing but e power minus lambda into lambda power x by x factorial. Now, we are going to simplify this equation, that is summation of x equals to 0 to infinity x into e power minus lambda into lambda power x minus 1 into lambda. Lambda power x can be written as lambda power x minus 1 into lambda. So here in the denominator we can write x factorial as x into x minus 1 factorial. So we can cancel both in the numerator and denominator we can cancel x here. Then we are remained with lambda and e power minus lambda, which are the constants. So let us take it out. Lambda into e power minus lambda, summation of x equals to 0 to infinity lambda power x minus 1 by x minus 1 factorial. So this is nothing, this is the simplified form of the previous equation. Now we are going to just expand this e power minus lambda of, how do you expand this? It is 1 plus lambda square by 2 factorial plus and so on. So that means what? This is nothing but the expansion of e power x, where in place of x we are having lambda. So how can we write it is lambda into e power minus lambda into e power lambda, right? So e power minus lambda and e power lambda will be getting cancelled. So we are remained with lambda. So therefore mean of the Poisson distribution is nothing but lambda. So here E of x is equals to lambda. This is nothing but the mean of Poisson distribution. Now in the same way, similarly, you can derive the equation of variance of Poisson distribution. Let us see here what is the variance of Poisson distribution. We know that V of x is equals to E of x square minus E of x whole square. So this is the variance of Poisson distribution. So here we have already got the value of E of x, which is nothing but lambda. So E of x whole square is nothing but lambda square. So we are considering it as equation 1. See here, we are considering it as equation 1. So now we have to just find out the value of E of x square. That means what? E of x square is equals to summation of xi square and p of x, where summation of x is equals to 0 to infinity x square. What is p of x, which is nothing but e power minus lambda into lambda power x by x factorial, correct? This is p of x. But we are also writing x square as x into x minus 1 plus x, which is also equal to x square, right? Because if you multiply x square minus x plus x and minus x will be getting cancelled, and you will be again getting the same thing. So here we are writing this as p of x only. Now we are just multiplying it with p of x, x into x minus 1 into p of x and x into p of x. So here what happens is, now by simplifying that, p of x can be written as e power minus lambda into lambda power x by x factorial, and here x factorial is written as x into x minus 1 into x minus 2 factorial, because x into x minus 1, x into x minus 1 can be getting cancelled here. So now we are remained with this one. Now if you expand this, you will get 1 plus lambda square by 2 factorial and so on, which is nothing but e to the power of lambda. So by substituting these values, and we will get e of x square, and by substituting e of x square in the variance equation, then you will get v of x is equals to lambda. That means what? Mean, we got it as lambda. Variance, we got it as lambda. Now what is the standard deviation, which is nothing but square root of lambda, because standard deviation is nothing but the square root of the variance. So it is square root of lambda. Standard deviation of Poisson distribution is positive square root of variance. Now mode of the Poisson distribution. Here mode of the Poisson distribution, you can give it as integral part of lambda. Integral part of lambda where lambda is not integer. If lambda is not integer, then you have to take only the integral part of lambda. If you consider, if you are having lambda is equals to integer, then the integral part will be lambda and lambda minus 1. So if lambda is equals to integer, then mode is lambda comma lambda minus 1. If lambda is not integer, then you have to just take the integral part of lambda. So integral part of lambda is the mode. It will become the mode of Poisson distribution. So now let us see what is recurrence relation of Poisson distribution. Here we already know that p of x is equals to e power minus lambda into lambda power x by x factorial, which is nothing but the first equation. Now if you consider the next term, that is x plus 1, then you will get it as e power minus lambda into lambda power x plus 1 by x plus 1 whole factorial. So this will become the equation 2. Now you have to divide equation 2 by equation 1 in order to get the recurrence relation. So if you divide e power minus lambda power x plus 1 by x plus 1 factorial, and if you divide by 1 equation 1, then it becomes reciprocal if you multiply, right? So x factorial into e power minus lambda into lambda power x. Here e power minus lambda and e power minus lambda gets cancelled, and you can write x plus 1 as x plus 1 into x factorial, correct? Here also you can write lambda power x into lambda by x plus 1 into x factorial. into x factorial by lambda power x. So lambda power x gets cancelled, x factorial and x factorial also gets cancelled. Now you are remained with lambda by x plus 1. That means p of x plus 1 by p of x is lambda by x plus 1. So if you cross multiply, then you will get p of x plus 1 is equals to lambda by x plus 1 into p of x. So this is nothing but the recurrence relation. Now, what are the conditions to apply Poisson distribution? Here there are few conditions. The number of trials are large. In the Poisson distribution, number of times the experiment is performed will be the greater. That means you will have more number of trials. And the second one is the occurrences are real. Here the real occurrences will be there. And in the third one, the probability of success is very small, that is very close to 0. That means what? Probability of success, where you can consider it as P, right? P is the probability of success and Q is the probability of failure. So probability of success is very small, which is very close to 0. So now coming to the fourth point, lambda is equals to NP is always a finite quantity. Okay, it's a finite quantity. Lambda is equals to NP is a finite quantity. So these are the conditions to apply Poisson distribution. Now let us solve some of the problems related to Poisson distribution. Here the first one is the probability that an individual suffers from certain injection is 0.001, right? So that means what? The probability of success is very small, which is near to 0. That means close to 0. So then find the probability that out of 2000 individuals, exactly 3 suffers from a bad reaction. You have to find exactly 3. That means let us write what is the given information. Solution. Given there are total number of individuals are 2000, right? N is equals to 2000. Now the probability P is equals to 0.001, which is given in the question. Okay, now we are going to find what is lambda. Lambda is nothing but NP, correct? NP, which is equals to 2000 into 0.001, which is nothing but 2. So this is the value of lambda. Now the first one let us take, which is exactly 3. That means P of x is equals to 3. Which is equals to, we are having the formula e power minus lambda into lambda power x by x factorial. Okay, e power minus 2, lambda is nothing but minus 2. Sorry, lambda is nothing but 2. So 2 power x is nothing but 3 by 3 factorial. That means e power minus 2 into 2 cube by 3 factorial. Now, if you compute this value, then you will get it as 0.1804. So, this is the probability of getting exactly 3 suffers from a bad reaction. So, now let us see the second one. Here, more than 2, that means more than 2 suffers from a bad reaction. That means x is greater than 2. If x is greater than 2, that means how can we find whether there are 2000 individuals. In 2000 individuals, you are just finding greater than 2. That means it is not possible, right? So we will find out in this way. 1 minus of P of x is equals to 0 plus P of x equals to 1 plus P of x equals to 2. So in this way, you will find out P of x greater than 2. So by substituting all the values, e power minus lambda, that means lambda value is 2, minus 2, 2 power 0 by 0 factorial, e power minus 2, 2 power 1 by 1 factorial, 2 square by 2 factorial. So by solving this equation completely, then you will get 1 minus 0.6762. So 1 minus 0.6762 is nothing but 0.323. That means the probability 0.323 probability of members can be affected. More than 2 suffers from a bad reaction. That means what? more than 2 suffers from a bad reaction. What is the probability? That is 0.323. Now we are done with the first one and we are done with the second one. Now coming to none suffers from a bad reaction. That means what? Exactly P of x is equals to 0, right? So now let us solve it. Here the third one, P of x is equals to 0. That means e power minus lambda into lambda power x by x factorial. By substituting all those values, you will get it as e power minus 2 power 0 by 0 factorial. 2 power 0 is 1, 0 factorial is also 1. That means e power minus 2 is nothing but 0.135. So in this way you can find out the solution. That means it is also the similarly, you have to just concentrate on the formulas and you have to learn those formulas in order to solve the problems. So now coming to the next one, here it is more than 1. It is more than 1 suffers from a bad reaction. That means what? P of x is greater than 1. Okay, P of x is greater than 1 means 1 minus P of x equals to 0 plus P of x is equals to 1. Okay, this is the equation. So in this way you can find P of x greater than 1. So now 1 minus, what is P of x equal to 0, which is already, we have got the value 0.135, plus P of x is equals to 1. Did we get the value? No. P of x is equals to 1 is nothing but e power minus lambda power 1 by 1 factorial. That means now if you solve this, 1 minus 0.135 plus 0.2706. Now by simplifying this one, by calculating this, you will get it as 0.593. So in this way you have to find out all the values from the given formula. Okay, so now what is the last one? It is between 1 to 4. That means find the probability that out of 2000, between 1 to 4 suffers from a bad reaction. That means what? Let us take it here, between 1 to 4. That means probability of 1 less than x less than 4, which is nothing but probability of x is equals to 2 plus probability of x equals to 3, because 1 and 4 are excluded, they are not included. So e power minus lambda into lambda power 2 by 2 factorial plus e power minus lambda into lambda power 3 by 3 factorial. So now by calculating this, you will get it as 0.2706 plus 0.1804. So now 0.451 will be the answer if you calculate the value. So now in this way you have to solve the problem of Poisson distribution. So now let us see one more problem, which is if 2% of light bulbs are defective from a sample of 100 bulbs. That means what? Total number of given, let us write the given information, solution. Given information is n is equals to 100 bulbs. 100 bulbs are given and out of 100 bulbs only 2% of light bulbs are defective. That means what? Probability of defective is 2%. That means 0.02. Okay. Now find the probability that exactly 1 is defective. That means let us find what is lambda here. Lambda is equals to 100 into 0.02, right? Because lambda value is nothing but n into p. So 100 into 0.02, which is nothing but 2. Now exactly 1 is defective. Exactly 1 is defective means P of x is equals to 1, right? Here if P of x is equals to 1, then by substituting all the values in the formula, we will get it as e power minus lambda into lambda power 1 by 1 factorial, right? E power minus 2 into 2 is the value. That means if you calculate e power minus 2 into 2, you will get it as 0.2706. Now let us see the second one. This is the first one. Now at least one is defective. That means what? At least one is defective means x is greater than or equals to 1, right? So if x is greater than or equals to 1, that means you cannot find, because if you add 1 plus 2 plus 3 and so on up to 100, then it is a difficult task. So we are going to just subtract from 1. 1 minus p of x is equals to 0. So if you find, then you will get at least one is defective. That means 1 minus e power minus lambda into lambda power 0 by 0 factorial. So you will get the value as 0.865. So in this way you can find at least one is defective. So now we are done with the second one. Let us go with the third one. Exactly 7 are defective. That means what? P of x is equals to 7, right? Which is the third question. P of x is equals to 7. That means if you substitute e power minus lambda into lambda power 7 by 7 factorial, then if you calculate this value, then you will get it as 0.0034. So this is the probability of 7 bulbs are defective. Exactly 7 bulbs are defective. So now let us find the fourth question, which is x is lying between 1 and 8. That means the probability of 1 less than x less than 8, which is nothing but probability of 2 plus 3 plus probability of 4 5 plus 6. You have to add till 7, right? Because 1 and 8 are excluded. So it is from 2 to 7. That means then if you add all these values, if you compute, that means what? E power minus lambda, lambda square by 2 factorial plus e power minus lambda cube by 3 factorial plus and so on, like this up to e power minus 2 to the power of 7 by 7 factorial. If you add all these values, then you will get the value as 0.592. So this is the value if you compute the probability of 1 less than x less than 1 less than x less than 8. So in this way you can find the problems of Poisson distribution. So now let us see the third question. It is nothing but pair of dice are thrown 200 times. So that means what here? What is given? That is the solution. You given part is also, writing the given part is also very important. So here n is equals to 200, right? So now the probability of getting some 9 is considered as success. That means you are throwing a pair of dice. That means 2 dice are thrown and you should get the sum as 9. That means 6, 3 will give you 9. 3, 6 will also give you 9. 4, 5 will give you 9. And 5, 4 will give you 9. So out of 36 outcomes, 4 only will give you sum as 9. That means what? 4 by 36 is the probability, right? That means P is equals to 4 by 36, which is nothing but 1 by 9. Okay, 1 by 9 is the P. Now you have to find lambda, which is equals to NP, where 200 into 1 by 9. That means lambda value is 22.22. So now considered as success. Then you have to find mean, variance and standard deviation. As you know, the first one is mean, which is the very easiest problem. This is the very easiest problem because mean is nothing but which is equal to lambda. Lambda value is 22.22. This is the mean. Second one is variance. Variance of Poisson distribution is also lambda, which is equals to 22.22. Now coming to the third one. This is standard deviation. Standard deviation is nothing but square root of lambda, right? Which is nothing but square root of 22.22. So square root of 22.22, it will give you 4.714. So it is the most easiest problem. Here we have given with n value and p value. Okay, so now you have to just find out the lambda so that Mean and variance are the lambda itself, and also standard deviation is square root of lambda. So in this way you have to understand the problem and then you have to solve it step by step by using the formula. Using the formula, then you can easily find out. Now let us see. Here, this is the most important question which we have. Average rate of arrival of people in a queue. See here, this is the most important question because it may be asked for the external exams, because it is the repeated question actually. So average rate of arrival of people in a queue is 1.5 per minute. Then you have to find a probability that at most 4 people will arrive in a given minute. That means at most 4. So let us write the first given data. Solution. Given data here, lambda is given as 1.5 per minute, right? That is nothing but it is equals to 3 by 2. 1.5 can also be written as 3 by 2, correct? So now you have to find out at most 4 people will arrive in a given minute. That means what? At most 4. It is nothing but x less than or equals to 4, which is equals to. Now you have to add from 0 to 4, right? Because it is at most, it is not at least. Plus p of x is equals to 3 and also plus p of x is equals to 4. So now e power minus lambda minus 1.5 into lambda power 0 by 0 factorial plus e power minus 1.5, 1.5 power 1 by 1 factorial, e power minus 1.5, 1.5 whole square by 2 factorial. So in this way you have to add each and every term in order to get at most 4 people will arrive in a given minute. So if you solve completely, then you will get 0.981. So using calculator you can find all the values very easily, and then if you add all these values, then you will get it as 0.981. So here at most 4 people will arrive in a given minute. So that means the probability is 0.981. Now coming to the next one, here it is asked that at least 5 people will arrive during an interview of 2 minutes. That means what? At least 5 is nothing but, second one, at least 5 is nothing but p of x is greater than or equal to 5, right? Greater than will be used for at least and less than is used for at most. That is the most important thing which you have to remember, because if you do it in a reverse way, then the answer might be wrong. So here, now we can also write it as 1 minus p of x is equals to 0 plus p of x is equals to 1 plus p of x is equals to 2 plus p of x equals to 3 plus p of x is equals to 4. So in this way we can find out the problem easily, because it is at least 5. That means here we are not given with the exact number of people, so here we are doing 1 minus of p of x less than 5. So if you just substitute and solve it, then you will get it as e power minus lambda, which is 1.5, 1.5 power 0 by 0 factorial, 1.5 power 1 by 1 factorial plus e power minus 1.5 into 1.5 power 2 by 2 factorial up to 4. We need to write it up to 4, because here 5 is included here in the at least. That means it will be excluded, right, by 4 factorial. So in this way we are going to find out p of x greater than or equal to 5. Then if you solve it using calculator, then you will get the value as 0.184. So this is the value of at least 5 people will arrive during an interview of 2 minutes. So this is the most important problem which we have to concentrate more on, these type of problems of Poisson distribution. Thank you for watching the video.